Hi, I am a tutor in Uplatz. Today we are going to discuss about Linux part 17, Linux USB drivers. Purpose of this course is learn how to implement Linux drivers for some of the complex USB devices. Undo cheese, good knowledge about Linux device development. Most notions which are not US specific are covered in our drivers course. To create a real working drivers, knowledge about USB devices, you want to write drivers for a good knowledge about USB specifications too. Linux USB basics, Linux USB drivers, USB devices, user specific representation, Linux USB communication, USB request blocks, initializing and submitting URBs, completion handlers, support writing USB drivers about devices, registering a USB driver, USB transfer without URBs. Linux USB basics, Linux USB drivers. USB core drivers, architecture independent kernel subsystem implements the USB bus specification outside the scope of this training. USB host driver, different drivers for each USB control hardware, usually available in the board support package, architecture and runtime dependent. Driver for devices on the USB bus, the main focus of the course, the platform independent. When you use Linux on an embedded platform, you can use any USB device supported by direct cameras, keyboards, video capture, Wi-Fi dongles, USB device controllers for Linux system, just a USB device controller in embedded systems. USB gadget drivers for Linux systems with the USB device controller. Typical example, digital cameras, you connect the device to a PC and see the camera as a USB storage device. USB device controller driver, platform dependent, supports the chip connecting to the USB bus. USB gadget drivers, platform independent. Examples, Ethernet gadget implements networking through USB. Storage gadget makes the OHCI a USB storage device. Serial gadget for terminal type of communication. See documentation docbook gadget in the kernel sources. Linux USB support overview. We have the user application system call interface. Fundamentally, we have the hardware where USB host controller, USB device is there. Then USB host control driver, Linux kernel, USB core and USB drivers, other kernel subsystems and system call interface, then user applications. USB host controller, OHCI and UHCI, two competing host control device, STD interfaces, OHCI, open host control interface, compacts implementation adopted as a standard for USB 1.0 and 1.1 by the USB implementers forum. Also used for Firewire devices. UHCI, Universal Host Controller Interface, created by introducing that other implementers use it and pay royalties for it only via licensed UHCI and others stuck to OHCI. This competition required to test devices for both host controller standards. For USB 2.0, the USB interface insisted on having only one standard. EHCI, extended host control interface for USB 2.0, the only one want to support high-speed driver transfers. Each EHCI controller contains 4 virtual HCD implementations to support full and low-speed devices on Intel and via chipsets, virtual HCD or UHCI. Other chipsets just makes have UHCI virtual HCDs. USB transfer speed, low speed up to 1.5 Mbps since 1.0, full speed up to 12 Mbps. Since USB 1.1, high speed up to 480 Mbps, it's USB 2.0. Linux USB basics, USB devices, operating system independent, described in the USB specification. Device represent the device connected to the USB bus, example USB speaker with volume control buttons. Configuration represent the state of the device, example active, standby, initialization. Interfaces, logical devices, speakers, volume control buttons. Endpoints, unidirectional communication pipes, either in device to computer or out of computer to device. Control endpoints used to configure device, get information about it, send commands to it, retrieve information. Simple, small data transfers. Every device has a control endpoint. Endpoint 0 used to configure the device at insertion time. The user USB protocol guarantees that the corresponding data transfers would always have enough reserved bandwidth. Interrupt endpoints transfer small amounts of data at a fixed rate. Each time the host asks the device for data, guaranteed reserved bandwidth. For devices requiring guaranteed response time, such as USB mice and keyboards, note different than hardware interrupts require constant polling from the host. Bulk endpoints, large sporadic data transfers using all remaining available bandwidth, no guarantee on bandwidth or latency, guarantee that no data is lost, typically used for printer storage and network devices. Isochronous endpoints also for large amounts of data, guarantee speed often, but not necessarily as far as processor. No guarantee that all data makes it through, used by real-time data transfer, typically audio or video. USB endpoint description structure. The USB endpoint description structure contains all the USB specific data announced by the device itself. Here are useful fields for driver writers. Underscore UI underscore B endpoint address, USB address of the endpoint. It also includes the direction of the endpoint. You can use USB underscore endpoint underscore DAR underscore mask with mask to tell whether there is a USB underscore DAR in or USB underscore DAR out endpoint. Example, if endpoint description.b endpoint address and USB underscore endpoint underscore del underscore mask underscore USB underscore n. Underscore USB U8 BM attributes the type of endpoint. You can use the USB underscore endpoint underscore type underscore mask bit mask to tell whether the type is USB underscore endpoint underscore expert underscore ISOC. USB underscore endpoint underscore expert underscore bulk underscore endpoint underscore expert underscore integer or USB underscore endpoint underscore expert underscore control and underscore UI underscore W max packet size maximum size in package that the endpoint can handle. Note that if greater than data sizes are used, data will be split in W max packet size chunks. Underscore UI and underscore B interval or interrupt endpoint device coding interval in milliseconds. Note that the above names do not follow Linux coding standards. The Linux USB implementation kept the original name from the USB specification. Refer document www.usb.org/developer.doc. Interfaces. Each interface encapsulates a single high-level function, USB logical function, example USB webcam, video stream, audio stream, keyboard control buttons. One driver is needed for each interface. Alternate settings. Each USB interface may have different parameter settings, example, different bandwidth settings for an audio interface. The initial state is in the first setting, number 0. Alternate settings are often used to control the use of periodic endpoints, such as by having different endpoints use different amounts of reserved USB bandwidth. All standard compliant USB devices that use isochronous endpoints will use them in non-default setting. The USB interface structure. One, USB interfaces are represented by the USB underscore interface structure. It is what the USB port passes to USB drivers. Struct USB underscore host interface star alt setting, list of alternate settings that may be selected for this interface in no particular order. The USB underscore interface, host underscore interface structure for each alternative setting allows access to the USB underscore endpoint underscore descriptor structure for each endpoint interface. All setting of I endpoint update is go to destination and send integer num alternate setting, the number of alternate settings. Struct USB underscore host interface star curve alternate setting, the current active alternate setting, init minor number. This interface is bound to for the drivers using USB underscore down descriptor. Other fields in the structure should not be needed by the USB drivers. Configurations, interfaces are bundled into configurations. Configurations represent the state of the device. Example, active standby initialization. Configurations are described with the USB host config structure. However, drivers do not need to access this structure. Devices are represented by the USB and for device structure. We will see later that several USB API functions need such a structure. Many drivers use the interface underscore tool underscore USB tab function to access the USB underscore device structure from the USB underscore interface structure that are given by the USB core. We have the USB device webcam configuration, active interface video input, control input, configuration standby, interface video input, output, interface audio, and control input, endpoint, control endpoint, input, endpoint, interface audio, control endpoint, input, endpoint. USB devices summary, hierarchy, device, configuration, interface, endpoint, 4 different types of endpoint, control, device control, access information, small transfers, guarantees, interpret, keyboard mice, data transfer at a fixed rate, guaranteed bandwidth, bulk storage, network printers use all remaining bandwidth, no bandwidth or latency guarantee, isochronous audio video guaranteed speed, possible data loss. USB, Linux USB basic users space representation, HTTP USB view, source code.net, graphical display of the contents, proc bus USB devices, USB view, USB tree, www.linux.usb.org, USB tree, also displays information from proc bus USB devices. Linux USB communication, USB request blocks. USB request block, any communication between the host and device is done asynchronously using USB request blocks, URBs. They are similar to packets in network communication. Every endpoint can handle a queue of URBs. Each URB has a completion handler. A driver may allocate many URBs for a single endpoint or use the same URB for different endpoints. See documentation, urb.txt, internal sources. Urban Life device driver creation assigned to an endpoint, submitted to the USB core, transferred device to the device, notification of the transfer completion can be reused. No, yes, it goes back to assigned to endpoint, else it goes to deletion. USB core controller driver and life of URB. URB structure, field of the URB structure useful to the device drivers. USB underscore device start down. Device the URB is sent to. Unset integer pipe, information about the endpoint in the target device. Integer status, transfer status, unsigned integer, transfer underscore class, instruction for handling the URB. Voice star transfer underscore buffer storing transfer data must be created with KMLOC. DMA underscore address underscore T transfer underscore DMA data transfer between when DMA is used. Init transfer buffer underscore none transfer buffer none. Init actual length of the data received as sent by the URB. USB underscore complete underscore T complete completion handler called when the transfer is complete. Void star context data blob, which can be used in the completion and the unsigned character star setup packet control orbs setup packet transfer before the data in the transfer buffer. DMA underscore adder underscore T setup adder underscore DMA control arm. Same but when setup packet is transferred with DMA. Init interval, isochronous and interpret orbs, following interval. Init error count, isochronous orbs, number of isochronous transfers which reported an error. Init start frame, isochronous orbs, sets or returns the internet frame number to use. Init number of underscore orb underscore packets, isochronous orbs, number of isochronous transfer buffers to use. Struct USB underscore ISO underscore packet underscore descriptor isochronous orbs, ISO underscore frame underscore destination 0 allows a single orb to define multiple isochronous transfers at once. Creating pipes functions used to initialize the pipe field of the orb structure. Control pipe USB underscore SND control pipe USB underscore receive control pipe. Bulk pipes USB SND bulk pipe USB receive bulk pipe. Interpret pipe USB send interrupt pipe USB receive interpret pipe. Isochronous pipe USB send isochronous pipe USB receive isochronous pipe. Prototype unsigned integer USB send bar receive control bulk init isochronous pipe send out receive in. Struct USB device start up and send integer endpoint. USB structure must always be allocated with the USB alloc URB function that is needed for reference counting used by the USB code. Include Linux bar USB.h struct URB star US alloc URB init ISO package number of isochronous packets the URB should contain equal to 0 for other transfer types. GFP underscore T mem class standard KMalloc class and check that it is not returned null. Allocation file typical USB URB alloc URB 0 GFP kernel. Freeing URB similarly you have to use a dedicated function to these URBs void USB underscore free underscore URB struct URB star URB. USB request blocks summary basic data structure used in any communication implemented by the struct URB type must be created with the USB alloc URB function. Should not be allocated statically or with KM alloc. Must be directed with USB free underscore URB. Linux USB communication installation and submitting orders. Initializing the interrupt orbs, avoid US and interrupt orbs, struct URB, start URB, struct USB devices, start tab, URB to be initialized, device to be sent to the URBR, pipe endpoint and device specific, transfer buffer size, completion enter, context for under, scheduling interval next page. This does not prevent you from making more changes to the URB field before your URB submission. The transfer class field need to be set by the driver. URB scheduling interval for interrupt and isochronous transfer, low speed and full speed devices, the interval units in frames millisecond, high speed devices, the interval unit in microframes by 8 milliseconds. Initializing value same parameter as in USB field init URB, except that there is no interval parameter. URB to be initialized, device to be send the URB to pipe endpoint and device specific transfer buffer size, completion handler, context for handler. Initializing control URBs, same parameters in USB and URB, except that there is a setup packet parameter URB to be initialized, device to be sent to the URB2 pipe endpoint and specifically setup packet, transfer buffer, transfer buffer size, completion handler, context are handler. Note that many devices use the USB underscore control underscore message function instead of data. Initializing Isochronous are no helper function as written manually by the driver media video USB video.c example. We can see this code. Allocate DMA buffers. You may use a USB buffer allocate function to allocate a DMA buffer. And device buffer size KML flags the output DMA controller address of the buffer. Allocate DMA buffer code to use these buffer. We use the URB no transfer DMA map and URB no setup DMA map. Setting your URB transfer flags to indicate the URB transfer DMA and or URB setup DMA are valid and submit. Example is URB transfer underscore flags pipe equal to URB no transfer DMA map. U transfer flags is equal to pipe equal to URB no setup DMA map. Device buffer size CPU address buffer and DMA address buffer. Freeing this buffer. Submitting URB, creating the initializing URB to submit KML flags. Flags is used by internal allocation performed by USB submit URB setting that should be used. GFP atomic called from the code which can split a URB completion handler. Odd or soft interrupts are called when the caller also spin lock. GFP no IO. In some cases, when block storage is used, GFP kernel in other cases. USB submit URB return value. USB submit URB immediately returns 0 request queued. ENO mem out of memory, ENO tab unplug device, ePipe star enters, eGain, too many queued ISO transfers. EF big, too many requests ISO files, val, invalid interval, more than one packet are in it. Canceling URB as example, to cancel a submitted URB without waiting in it, USB link, ULink, and link URB, struct URB, start URB, success returns, EIN, progress, failure, any other return value, it can happen when the orb was never submitted, when the as already been unlinked, when the orb is done with the URB, even if the completion handler has not been called yet. The corresponding completion handler will still be run and we will see URB status can reset. Cancelling URB synchronously to cancel the URB and wait for completion handlers to complete. This guarantee that the URB is totally idle and can be reused. Void USB, kill URB, struct URB, star URB, typically used in a disconnect callback or close functions. Caution: this routine must not be called in situations which can add speed in interrupt context in the completion handler or when holding a spin lock. See commands in driver USB for URB.c in kernel sources for useful details. Initializing and submitting URB summary. URB structure field can be initialized with helper function. USB field in URB, USB field bulk URB, USB field control URB, Isochronous URBs have to be initialized by hand. The transfer flags field must be initialized manually by each driver. They use the USB submit URB function to queue URBs. Submitted URBs can be cancelled by using USB unlink URB asynchronous and USB kill URB synchronous. Linux USB communication completion handlers. When is the completion handler called? The completion handler is called in interrupt context in only 3 situations. Check the error value in URB status after the data transfer successfully completed. URB status equal to 0. Errors happened during the transfer. The URB has unlinked with USB port. USB status should only be checked when the completion handler. Transfer status described in documentation USB error codes TXT. The URB is no longer linked in the system. Con reset, and the URB was unlinked by the USB unlinked URB. No ENT. URB was supported by USB kill URB. Shutdown. Error from the host controller driver. The device was disconnected from the system. The controller was disabled, or the configuration changed where the URB was sent. No tab. Device removed, often preceded by a burst of other errors, since a driver does not detect device removal events immediately. Transfer status. Two typical hardware problems with the cable or device, including the firmware. EPRO2 bit step error, no response packet received in time by the hardware or unknown USB error. EIR CQ CRC error, no response packet received in time or unknown USB error. Overflow amount of data returned by the endpoint was greater than either the maximum packet size of the endpoint or the remaining buffer size, Babel. Other error status values, in progress, URB not completed yet. Your driver should never get this value. Timed out. Usually reported by synchronous USB message function when this specified timeout was exceeded. E5 endpoint stalled for control endpoint. Reset this status with USB clear halt. ECOM during an IN transfer, the host controller received data from an endpoint faster than it could be written to system memory. ENSR during an out transfer, the host controller not retrieve data from the system memory faster enough to keep up with the USB data rate. Remote IO, the data read from the endpoint did not fill the specified buffer, and USB short not okay was set up in URB transfer class. EXDEV, Isochronous transfer only partially completed. Look at individual frame status of our details. EINVAL typically happens with an incorrect URB structure field or USB submit or function parameter. Prototype, the complete URB, the register values of the time of the corresponding interrupt, if any. Remember, we are in the interrupt context, do not execute call which may sleep, use the permit, etc. Complete as quickly as possible, schedule remaining work in a tasklet if needed. Completion and assembly. The completion handler is called interrupt context. Don't run any code which would sleep. Check the URB status value in this handler and to not before success URB status equal to 0. Otherwise, error status is scheduled. Documentation URB error codes .text. Rating USB drivers, support devices. What device does the driver support, or what driver supports a given device? Information needed by user space to find the right driver to load or remove after a URB hotspotting event. Information needed by the driver to call the right probe and disconnect driver functions. See later, such information is declared in a USB underscore device underscore ID structure by the driver init function. USB device ID structure 1. Defined according to USB specification and describing include Linux mod device data table.h underscore UHCI match flags, bitmask defining which fields in the structure are to be matched against, usually set with the helper functions described data underscore U6 ID vendor ID product user vendor and product ID assigned by the USB interface. I underscore U16 BCD device underscore LO underscore I product version range supported by the driver expressed in binary coded decimal BCD form. USB underscore U8 B device class B device subclass B device protocol class subclass of protocol of the device number assigned by the USB IF. Products may choose to implement classes or be vendor specific. Device classes specify the behavior of all the interface on a device. underscore U8, V interface class, V interface subclass, V interface protocol, class, subclass, and protocol of the individual interface, number of assigned by the USPIF interface classes only, specify the behavior of a given interface. Other interfaces may support other classes. Kernel underscore U long underscore T driver info. Kernel underscore U long underscore T driver info holds the information used by the driver. Usually it holds a pointer to a descriptor understood by the driver or perhaps the BOS flag. This field is useful to differentiate different devices from each other in the probe function. USB devices, declare support devices. USB device vendor product creates a USB device ID structure which can be used to match only the specified vendor and product ID used by most drivers for non-standard devices. USB underscore device underscore version vendor product I. Similarly, but only for a given version range, only used 11 times throughout the Linux 2.6.19. Declaring supported devices to USB device info, class, subclass, protocol, match, specifies class of the devices, USB interface info, class, subclass, protocol, matches a specific class of USB interface. The above two macros are used only in implementation of standard device and interface classes. Declaring supported devices, create USB device ID structures are declared with module device table, macro are in the below example. Note that module device table is also used with other subsystem PCA, PCIe, serial LIGO, ISA, PNP input, etc. Supported device summary. Driver need to announce the devices they support, the USB device ID structure needed for use space to know which module to unload or load, and for the kernel which driver code to execute when a device is inserted or removed. Most drivers use USB device to create the structure. These structures are then registered module device table USB XXX. Writing USB driver is simply USB driver. USB driver structure. USB drivers must define a USB driver structure. Constant character name. Unique driver name usually be set to the module name. Constant structured USB device ID star ID table. The table already declared with module device table. You need star probe structures, USB interface, star interface, INTF, constant structure USB device ID, star ID, probe callback, detail data, void, star disconnect, struct, USB interface, star INTF, disconnect callback, detail data. Optional USB driver structure fields, init star statement, structure USB interface, star INTF, PM message, and T message. Init star resume, struct USB star INTF, power management callbacks called before and after USB suspense and resume the device. Void star pre-reset, struct USB interface star INTF, void star post reset, struct USB interface star INTF, and call by USB reset composite device before and after it performs a USB port reset. Device registration, use USB register to register the device. Driver example is shown below. Your driver unregister, use USB deregister to register your driver. Example is shown below. Probe and disconnect function. The probe function is called by the USB core to see if the driver is willing to manage a particular interface on a device. The driver should then make checks on the information passed to it about the device. If it divides to manage the interface, the probe function will return 0. Otherwise, it will return a negative value. The disconnect function is called by the USB core when the driver should no longer control the device, even if the driver is still loaded and should do some cleanup. Context USB of kernel thread. The probe and disconnect callbacks are called in the context of the USB of kernel thread, so it is triggered to call functions which may sleep in this function. However, all addition and removal of devices is managed by the single thread. Most of the probe function work should indeed be done when the device is actually opened by the user. This way, this does not impact the performance of the kernel thread in managing of other devices. Probe function work. In this function, the driver should initialize load structures which it may need to manage the device. In particular, it can take advantage of information it is given for the device. For example, drivers usually need to direct endpoint addresses and buffer sizes. This to attempt to show and explain examples in detail. USB set INTF data, USB get INTF data, static inline void USB set INTF data, struct interface, start INTF void start data function used in proof function to attach the collected data, device data to an interface. Any pointer will do. Useful to store information for device, each device supported by a driver without having to keep a static data array. The USB get information init data function is typically used in the device open function to retrieve the data. Stored data need to be freed in a disconnect function. USB set ANTF data interface null. Plenty of examples are available in kernel sources. Writing USB drivers, USB transfers without URBs. The kernel provides two USB bulk message and USB control message helper functions that make it possible to transfer simple bulk and control message without having to create or reuse an ORB structure, initializing it, submitting it, and wait for its completion handler. Transfer without URBs constraints. These functions are synchronous and will make your code sleep. You must not call them from interrupt counters or with a spin.l. You cannot cancel your request as you have no handle on the URB used internally. Make sure your disconnect function can wait for these functions to complete. See the kernel sources, for example, using these functions. Model loading, declare supported devices interfaces, bind them to probe and disconnect functions. Supported device found probe functions for matching interfaces drivers are called. They are record interface information and register resources or services. Device sources are open. This call data access functions registered by the driver. URB are initialized once the transfer are over. Completion functions are called. Data are copied and from and to a user interface, user space. Devices are removed. The disconnect functions are called. The drivers are maybe unloaded. Advice for embedded system developer: if you need to develop USB device driver for embedded Linux system, develop your driver on GNU Linux development OS. The driver will run with no change on the target Linux system, provided you put code. All USB drivers are platform independent. Your driver will be much easier to develop on the OS because of its flexibility and availability of again development tools. References are given here. Next, Ethernet over USB. If your device does not have Ethernet connectivity but has a USB device controller, you can use Ethernet over USB through G_Ether USB device gadget driver config _USB gadget. Of course, you need a working USB device driver, generally available as more and more embedded processor, well supported by the NSRA, built-in USB device controller, plug in both ends of the USB cable. Ethernet over USB 2. On the OS, you need to have the USB net module, config _USB net, plug in both ends of the USB cable, configure both ends as regular networking devices. Example on the target device, mod probe G_Ether, config USB 0, 192.168.0.202, route and 192.168.0.200 USB on OS, mod probe USB net if config USB 0, 192.168.0.100 and 192.168.0.202 WSP 0 works great in IPAQ PDAs. Thank you.